Hey guys, Nick from Aguazio, here to show you one of our latest tutorials on deploying LLMs using MLRun. In this demo notebook, we are going to be grabbing a dataset, which is a list of articles, scraping those articles, chunking and indexing them into a vector store, and then finally deploying an open source Hugging Face model to an endpoint where we can make requests and get responses with a RAG enrichment using the data that we just downloaded. So let's go ahead and take a look. First thing we're going to be doing is setting up MLRun in our project. The first real thing we're going to be doing is setting up our vector database. So in this example, we are going to be using ChromaDB, but any vector store should work. And the model we're going to be using is Microsoft's Phi2. But again, any open source Hugging Face model should work in this example. The dataset is a news dataset, so I actually have it open right here, where we have a list of topics. There's 8 different topics in this dataset. And then each record has, again, a topic and a link to the article itself, as well as some other metadata information, including the title. What it does not have is the content of each of these articles. So that's something that we're going to be doing as part of our data prep, is grabbing the actual source and the actual content from each of these articles. And in order to do that, we're going to be using this fetch vector DB data function. We're creating an MLRun function pointing to a Python file, running it as a job with a Docker image. The Docker image here is built with this Docker file, but you can also build it using MLRun. In order to run it, we're going to pass in the name of the MLRun function that we just created, as well as the entry point within the Python file. And finally, it's expecting our data set. This is, again, this data set right here. We can look here in the logs, and we can see that it is indeed fetching pages, 80 out of 80, and the data set downloaded and logged. In our case, there are 8 different topics, and we're grabbing 10 articles per topic. So that gives us a total of 80. Under the hood within our Python file, we're doing a few different things. One is just grabbing the raw data like we saw in the notebook, grabbing the latest 200 articles by the published date, and then grabbing 10 articles per topic. Remember, there are 8 different topics, and 10 articles per topic will give us a total of 80 different articles. From here, we're going to be grabbing the article content itself using the link. And to do this, we're using the LangChain web base loader. We just pass in a list of the URLs, and then we say loader.load. In this case, we're actually using loader.aload, which is going to do the loading asynchronously and do it in parallel. In this case, 2 requests per second, much faster and much more efficient. You'll just need to be careful to not make too many requests per second. Finally, we are adding the extra metadata back into our pandas data frame, not just the raw metadata itself. In this case, the description, if it has one, we're grabbing it, and if not, we're saying none. And then the page content, which is what we really care about, we're running it through this clean function, which you are getting from clean text. This will remove all of like the ugly formatting and white space and just weird stuff you get when you're doing web scraping. And then finally, we are logging our dataset to be used in the next step. In the next step, we are going to be taking this data and chunking and indexing it into our vector store. Like I mentioned, we're using ChromaDB, but this applies to any vector database out there. In order to do this, we're creating our MLRun function, pointing to a Python file, which we'll touch on in just a moment, running it as a job with a Docker image, and then we'll say project.run function, passing in the MLRun function we just created, as well as the input dataset. It's expecting a parameter called df, and we're passing in the output of our previous job. It's also expecting a cache directory, which is going to be storing tokenizers and models and other large files. We can take a look at the logs. We can see it's downloading the dataset from our previous step, creating a collection called My News within the vector store, creating all the embeddings, and then storing the documents inside the vector database. Under the hood, what this is doing is, first of all, getting a Chroma client, and then for the sake of the demo, we are deleting and recreating a collection called My News. From there, we are grabbing the documents from our pandas data frame and turning them into LangChain documents. And the reason we're doing that is so that we can use the recursive character text split. We're doing this to split up the documents into smaller pieces so that we can have more relevant chunks within our context. The model we're using is the Microsoft Phi2 model, which is quite a good model, especially for a very low parameter model that can fit on your CPU. However, the context length is only 2048, so not small, but not big either. So we want to make sure that we can fit at least a few chunks into our context length. So we're using a chunk size of 500 with no overlap. And then finally, we are adding all of those documents to our vector store and saying that the vector DB was created. So now is the most important part where we are serving the open source Hugging Face model. Like before, we are creating our MLRun function, pointing to a Python file and a Docker image. Unlike before, the kind is no longer job, it is now Nucleo. Nucleo being an open source real-time serverless framework that is really excellent for doing things in real time. That includes model serving. From there, we're specifying a few infrastructure things like environment variables, scaling behavior, as well as HTTP timeouts. We are upping the default timeout just because it's going to take a little bit longer to generate on the CPU. From there, we will deploy it using project.deploy function and pass in the function that we just created and configured. This will create a pod on Kubernetes, build a Docker image, as well as expose it to some HTTP endpoint. So before taking a look at the Python code, let's take a look at what it looks like in practice, where we are defining a question and a topic. In this case, the question is just what we're asking of the context and of the knowledge that we've just retrieved, and the topic in this case being used for filtering. So if you remember from our data set, we have 8 different topics, and this topic that we pass in is only going to be used for generation. So in this case, only documents tagged with science are going to be used in generating the response. From there, we invoke the endpoint, passing in our question and our topic, and we get a few things back. As part of that response, we're getting the model response itself, which is actually quite good and is reflective of the context that we retrieved. We have the sources, in this case, just a list of those links. In this case, we can see it's an article about SpaceX, which is also reflected in our response. And then we have the formatted prompt, which includes the user's question, as well as the different chunks of data that were retrieved from the vector store. And we can see that this actually looks pretty good. So for example, we can see there's mention of debris and space junk, and there's mention of efforts to send humans to Mars, both of which are also reflected here in our response. So let's take a look at what's going on in our serving.py. First of all, there is a little bit of setup, our prompt template, as well as a helper class that's going to be used for stopping generating whenever the model sees a certain token. But in terms of the real stuff, we have 2 main functions. One is called a init context, and one is called handler. Init context is where we're going to be defining anything with the global state. That includes our connection to our vector database, as well as our Hugging Face pipeline that's going to be used for generating the text. This is initialized once, and then it stays in memory. Then we have the handler, and this is what's happening whenever we receive a request, and this is going to be happening per event. Unpacking the payload, setting a scene if we need it, querying the vector store. This is where we are passing in the user's question, a number of results, as well as filtering by the metadata, in our case by the topic. So from there, we are constructing the prompt using our prompt template that we saw above. And then finally, using our Hugging Face pipeline to generate the response. Once we clean up the response a little bit, we are returning a dictionary that includes the sources, prompt, and response, which we saw the output of on the right-hand side here. Finally, the last part of this notebook is running this whole thing as an end-to-end workflow, so that instead of interactively running each of these steps in a notebook, you can run it as a whole pipeline. I'm not going to run through that in detail because it's essentially what we just saw, but you can see that the output here is indeed a pipeline where each of these steps has the same experiment tracking information that we saw in the previous steps.